Hello, so today we're going to be learning about curve sketching. It's a unit in calculus. So different areas would include x-intercepts, y-intercept, critical points, increase and decrease interval, curve and graph, chart of concavity, POI, summary. So these are different things that require curve sketching. And we're going to dive into each of them. We're going to learn about each part of curve sketching, and by the end of the video you should be prepared to do some curve sketching practice questions. So let's get started. So zeros and x-intercepts. In order to find zeros and x-intercepts, we're going to check out dividing polynomials by synthetic or long division and solving polynomial equations. So what we do is we list all factors of the constant term. We put those factors into f of x, or the function, and if that factor that we input into the function, if it equals 0, then it is a factor, and if it does not equal 0, then it is not a factor. Once you find a factor using synthetic or long division to find the rest of all, once you find a factor, use synthetic or long division to find the rest of the factors. You'll likely calculate a trinomial into which you'll factor, then have a fully factored form of the original function, and then you'll have all x-intercepts as well. Don't forget to do a therefore statement with your x-intercepts, and you can list them with the coordinates as well. So y-intercepts. The y-intercept is where the function crosses the y-axis, and the x value of the coordinate or point is 0. To get the y-intercept, or more specifically the y value of the y-intercept coordinate or point, you substitute x equals 0 into f of x, or an x value of 0, into the function. We substitute x equals 0 because the y-intercept lays upon the graph on the y-axis. The x value of the coordinate or point of the y-intercept is always 0. And don't forget, again, your therefore statement equaling like the y-intercept, and then you can lay your findings there. Critical points. So to find x values of critical points by finding the derivative using power rule, product rule, quotient rule, chain rule, constant rule, and then finding derivatives or the derivative function. So that's some backup knowledge there. You're going to be using what you've learned in advanced functions and calculus thus far in order to do curve sketching. So you then set the derivative that you have found equal to 0 and solve for x by factoring or isolating x. And then once you find what x equals, those are the x values for your critical points. To find y values of critical points, you input x values found or calculated through the method above into f of x, the function, and then calculate the result. The result is the y value of the critical point. So you find derivative, So with x value found of the critical point, input into f of x for the y value of the critical point, and then again, do your therefore statement. So increasing and decreasing intervals. First you find the first derivative, then you solve for x with first derivative by factoring or isolating x, and then you create a number line or chart with x values found. Be sure to include infinity or negative infinity as well. Input numbers, so we input numbers below and above the x values on the number line or chart, and we input them into the derivative function to indicate if it's increasing or decreasing by the calculation or answer being positive or negative. You can also check out increasing or decreasing intervals or increasing and decreasing functions. That video will help you as well. And then if the answer is positive or negative, it'll remind you if it's increasing or decreasing, or it'll indicate if it's increasing or decreasing, indicating on number line or chart with positive or negative symbol if it is increasing or decreasing. Don't forget your therefore statement of the increasing and decreasing interval. And that'll be everything for that. Here's an example of what a number line could possibly look like for increasing and decreasing intervals. Points of inflection and chart of concavity. So this one is the second derivative. Find the second derivative and equal to 0 and solve for x. So second derivative, set it equal to 0 and solve for x by factoring or isolating x or whatever you need to do. Find the second derivative by taking the derivative of the first derivative, and then set the second derivative equal to 0 and solve by factoring or isolating x. By doing that, you find the x value of the point and of the point coordinate of the POI. Input x coordinate of POI into f of x or the function to find the y value of the point or coordinate. The full point of inflection found, do mathematical therefore statement, so POI. Moving on to the chart of concavity. Okay, so for the POI and chart of concavity, create chart for analyzing the concavity with x value found from setting the second derivative equal to 0 and solving. Indicate numbers above or below and in between x value of the POI on the chart. You'll be inputting these numbers into the second derivative to indicate whether it is positive or negative, aka concave up or concave down. If the calculated result is positive, then it is concave up. If the calculated result is negative, then it is concave down. Indicate with these two symbols here if it is concave down or concave up. And then again, positive for concave up and negative for concave down on chart. And then the chart of concavity is complete. Here's an example of what the chart might look like. I'll give you a moment to write that down. Okay, moving on. The number is a value in between the x values to input into the second derivative to see if it is concave up or concave down. You can also do intervals as well. The summary, so different parts. So in order to complete a curve sketching questions, you'll need x-intercepts, y-intercepts, critical points, increasing or decreasing intervals, POI and chart of concavity, a summary, and a sketch and graph. And I also recommend you do a checklist like I do. So for this is the summary. So we have x-intercepts, y-intercepts, critical points, increasing or decreasing intervals, POI. We label what the original function is, and then we do a graph, and we highlight that graph. So if it is concave up and concave down, so this would be blue, and this would be pink. Sketch and graph. So label all information exemplified in the graph. Go through checklists and double check work. Proper scale, y-axis and x-axis labeled, and highlight where needed. So there's an example of a scale and of a graph. And then here you would put the function. And that's everything I have for you today. So hopefully that was helpful. We're going to be doing a few practice questions within the next video. So thank you very much for watching and have a wonderful day.